Today we're going to practice solving systems of two linear equations where we have to multiply both of the equations by a different number so that when we add those two equations together, one of the variables will be eliminated. So let's get started. So in this first system, we have the equation 2x plus 5y equal to 3, and the second equation is 3x plus 4y equal to 1. So now we're going to have to multiply each equation by a different number so that when we add them, one of the variables is eliminated. Now we can choose to eliminate either the x variable or the y variable. It doesn't matter which one. Usually I choose the one that's going to result in smaller coefficients. So I approach this in the same way I approach adding fractions. So if we were adding the fractions 1/2 and 1/3, in order to add these two numbers, we need a common denominator. So in this case, the common denominator is 6. 6 is the least common multiple of 2 and 3. So for 1/2 to have a denominator of 6, we'd have to multiply the denominator by 3. We have to multiply both the numerator and the denominator by 3. So this becomes 3/6. And for this second fraction, we have to multiply the denominator by 2. So we're multiplying by 2 over 2. And then we have 2/6. Adding these two together, we end up with 5/6. So I'm going to take the same approach here. I'm going to eliminate the variable x. So we're going to find the least common multiple. Really, you can find any common multiple, but it's easiest to find the least common multiple of 2 and 3. Again, that's still 6. So we're going to multiply 2x by 3 to give us 6x. But you can't just multiply one term in the equation by a number. You have to multiply the entire equation by that number. So we're going to multiply the first equation by 3. Now this gives us 6x plus 15y equal to 9. Now this second equation, in order for 3x or 3 to become 6, we'd have to multiply everything by 2. But we also want the variable to disappear. So if the first equation is 6x, we want a negative 6x for the other equation. So we're going to multiply the second equation not just by 2, but by negative 2. This results in negative 6x minus 8y equal to negative 2. And then when we add these two equations together, 6x plus a negative 6x, that's 0x. 15y plus a negative 8y, or 15y minus 8y, is 7y equal to 7. And then solving for y, we end up with y equal to 1. And then plugging this value into either of these equations, go back to the original two equations, and we're going to plug that y value of 1 into one of them. I'll pick that first equation. So we have 2x plus 5 times 1 equal to 3. This is 2x plus 5 equal to 3. Subtracting 5 from both sides, we have 2x equal to negative 2. And then dividing both sides by 2, we have x equal to negative 1. So the answer is negative 1, 1. Let's go ahead and check our answer by plugging these values into both equations. So for the first equation, we have 2 times negative 1 plus 5 times 1 equal to 3. Negative 2 plus 5 equal to 3. This is 3 equal to 3. That's a true statement. And then with the second equation, we have 3 times negative 1 plus 4 times 1 equal to 1. Negative 3 plus 4 equal to 1. 1 is equal to 1. So the solution to this system is an ordered pair, x, y, where x is negative 1 and y is 1. So let's try one more. So we have the system 7x plus 8y equal to negative 9 and negative 4x plus 9y equal to negative 22. So looking at the coefficients with the x variable, we have 7 and 4. So the least common multiple there will be 28. And then between 8 and 9, the coefficients of these y variables, least common multiple there is 72. So I will typically pick the arithmetic that's going to lead to the smaller numbers. So if we look at eliminating the variable x, I'll be multiplying this first equation by 4 and the second equation by 7, which means we would be multiplying negative 22 by 7. But if we eliminated the y variable, we'd be multiplying 22 by 8. So not much difference here. So I will go ahead and eliminate the x variable. But again, you can also eliminate the y variable instead. So as I have mentioned before, I'll typically draw an arrow and then indicate what arithmetic I'm doing. So I'm going to multiply this first equation by 4. We get 28x plus 32y equal to negative 36. And then with the second equation, I'm going to multiply everything by 7. So 7 times negative 4x, that's negative 28x. And then 7 times 9y, that is plus 63y. And this is equal to 7 times negative 22, negative 154. And then solving by elimination, we're going to add these two equations together. So as planned, our x variable is eliminated. And now we have 95y equal to negative 190. And then dividing both sides by 95. Our y value is equal to negative 2. Again, we're going to plug this value back into either of these two equations. I'll pick the second one this time, but again, you can pick either of these equations. So we have negative 4x plus 9 times negative 2 equal to negative 22. So negative 4x minus 18 is equal to negative 22. Adding 18 to both sides, we have negative 4x equal to negative 4. And dividing by negative 4, we get x equal to 1. So our solution is the ordered pair 1, negative 2. So checking our answer, we'll have 7 times 1 plus 8 times negative 2 equal to negative 9. So this is 7 minus 16 equal to negative 9. And we have negative 9 equal to negative 9. So the first equation works. And then with the second, we have negative 4 times 1 plus 9 times negative 2 equal to negative 22. Negative 4 minus 18 equal to negative 22. So negative 22 equal to negative 22. Another true statement. Again, the answer is the ordered pair where x is equal to 1 and y is equal to -2. You can also write your answer. Go ahead and write that ordered pair as xy equal to 1, -2. So making it clear that the first coordinate is x and the second coordinate is y. This is not as important when you're using x and y because it's customary that the first coordinate is x and the second coordinate is y. But if you have a system that has different variables, it's always nice to indicate which one is the first variable and which one is the second variable. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So for this first problem, turns out the least common multiple for the x variable is 15, and the y variable is also 15. I chose to eliminate, in this case, the y variable. I did so because one of the coefficients was negative and the other was positive. So we can multiply both equations by a positive number. So multiplying the first equation by 5, we end up with 25x minus 15y equal to 120. And then the second equation by 3, we have 9x plus 15y equal to 84. Adding these two equations, our y variable disappears, and we can solve for x. And we get a value for x of 6. Plugging it back into either of these equations, we end up with a y value of 2. And so the answer is the ordered pair 6, 2. For this second problem, I ended up solving this in a slightly different way. So looking at our coefficients, for the x variable, we have 3 and 4, so our least common multiple there will be 12. And then for y, we have 7 and 3, so a least common multiple of 21. So I decided to eliminate the x variable. But do notice that the x coefficient for both equations is a positive number. And I multiplied both equations by another positive number. So we end up with 12x in the first equation and 12x in the second equation. So if we added these two equations, we'd end up with a positive 24x. So instead of adding the equations, I subtracted the second equation from the first equation, because subtraction is addition of a negative. But when you do this, you have to subtract all the terms in the equation. So here we have 12x minus 12x, resulting in 0x, so we eliminated the x variable. And then we have 28y minus a negative 9y. So this is 28y, well, minus a negative, this is plus 9y, resulting in 37y. And then 64 minus 27 is 37. Solving for y, we end up with y equal to 1. And then we can plug this value for y into either equation. And then solving this equation, we end up with x equal to 3. And the answer is an x coordinate of 3 and a y coordinate of 1. Drop any questions you have in the comments. Continue practicing solving systems of linear equations using the elimination method, and I'll see you in the next video.